Good morning, students. My name is Uttam Khoth, working as a assistant professor in SIT COE Yadrao. Since from 8 years, I am handling the subject engineering chemistry in the same institute. As we know that our college is affiliated to DBAT Lonere. So as per the syllabus contained in the DBAT Lonere University, the engineering chemistry subject is having 5 topics. Unit number 1, water treatment, includes in this topic we are going to discuss some characteristics of water and their determination, like hardness of water and DO of the water sample, and how we can purify the water by some methods. This content we have to see in this topic. Unit number 2, phase rule. In this topic we have to discuss about phase rule and some important terms in the phase rule, nothing but the phase, components and degree of freedom. And after that you have to see some examples of one compound system and two component system. Unit number 3, metallurgy. In this topic we are going to see about the ores and how we can concentrate the ores by physical and chemical methods, and after that we have to see how we can get the refined metals by refining process. Unit number 4, fuels and lubricants. In this topic we are going to see about properties of the fuels and lubricants and determination of that some contents in the fuels and lubricants by some methods. Unit number 5 includes some basic concepts about electrochemistry, like conductance and their various types, and after that you have to see some important theories in the electrochemistry. This much part you have to see in the syllabus, includes 5 topics. But before going to start with the actual syllabus of engineering chemistry, I would like to discuss some basics points from chemistry which are related to engineering, deals with the chemistry that you have learnt already in the 12th science and 11th science, about polymers, some about instrumental methods of chemical analysis, some about corrosion. So today we'll start with some basic concepts about polymers. So before that, here is one of the quote from late Dr. APJ Abdul Kalam. If you fail, never give up, because fail means first attempt in learning. End is not the end. In fact, end means effort never dies. If you get no as answer, remember no means next opportunity. So let's be positive. So let us start with our discussion about polymers. In this concept we are going to see some part about polymer, nothing but what do you mean by polymer, mean by monomer, polymerization. After that we have to discuss about plastic, and after that we have to see some examples of plastic, nothing but we can say resin. Okay, so how we can define the polymer? First of all, that you have learned in the 12th science, polymers is nothing but a high molecular weight compound formed by linking a large number of repeating units, nothing but the monomers, together is called as a polymers. So how we can define? It is a high molecular weight compound formed by linking large number of repeating units together is called as a polymer. We can take the examples of various polymers as polyvinyl chloride, polyethylene, nylon 6, nylon 6,6, starch, natural polymer we can say starch, because we can say our life starts with the polymers. Proteins are the very first molecule of life. Polymer is a generic name given to large number of compounds having high molecular weight. Okay. Second term in the case of the polymer is the monomer. Monomer is nothing but the repeating unit present in the given chain of polymer is nothing but the monomers. Okay, we can define in other way the simple chemical species having low molecular weight used to form a polymer is called as a monomer. Okay, means that we can take the example in the slide. Here it is one of the example, vinyl chloride on polymerization formation of PVC, nothing but the polyvinyl chloride. Here it is the polymer and we can say these are the monomers. Vinyl chloride is the monomer for the PVC. Okay, because these are the repeating units in the PVC. Okay, third term, nothing but the polymerization. So how we can define the polymerization? The process by which monomers combine to form a polymer is known as a polymerization. Or in other way we can define process in which large number of smaller molecules, simple chemical species, nothing but the monomers, linking together to form a large molecule under specific conditions of temperature, pressure and catalyst is known as a polymerization. We can take the same example, vinyl chloride is on polymerization, means that n numbers of vinyl chlorides is on polymerization. We can get the long chain of straight chain polymer, nothing but the PVC. After that we can take here in right hand side we can see in the bracket lower down n is there. N is nothing but the degree of polymerization, because we can say the number of repeating units in the chain of polymer molecule is called as a degree of polymerization. Next one we have to see about plastics, as I said. So how we can define the plastics? Plastic is nothing but the high molecular weight compounds which can be molded into any desired shape when subjected to heat and pressure in the presence of suitable catalyst are called as a plastics. The name plastics refers to its meaning that these are polymers which mold themselves into articles by heat and pressure. As mostly plastics are synthetic, these are also known as synthetic resins. Over the years, the plastics have taken the place of metal in various uses. We can say plastics having some good characteristics, we can say some properties. Likewise, they are lightweight, they are having corrosion resistance, they are having low fabrication cost, they are having good thermal and electrical insulator, they are easy for molding into any desired shape, low thermal expansion of coefficient, and we can say decorative surface effects. These are the nothing but the some of the characteristics of plastics. During the manufacturing of any kind of plastic material or plastic articles, on the basis of setting manner in the final stage of manufacturing of any kind of articles of plastics. They are having classified into two classes. Number one, thermoplastics. It can be called as the thermo softening plastics, and number two is the thermo setting plastics. So we have to discuss this part in comparison manner. Here it is. Both the plastics, as I said, thermoplastics and thermosetting plastics can be get explained by means of comparison. Number one, formation. We can say thermoplastics are get formed by addition polymerization, and thermosetting plastics are formed by condensation polymerization. Okay, means that in case of the thermoplastics, they are formed by only addition of monomers. There is no loss of any kind of smaller molecules, nothing but the addition polymerization. And in case of the thermosetting plastics, they are formed by condensation polymerization. In this case, monomers are get condensed each other, and during condensation, smaller molecules like HCl, H2O, methane are get escape, are get, we can say, having as a byproducts. Okay, nothing but the condensation polymerization. Number two, the thermoplastics having consist of linear long chain structure with limited crosslinks like this. Okay, and the thermosetting plastics consist of three-dimensional crosslink network like this, Okay, we can say here having networks type structure. The thermoplastics having smaller molecular weight, and thermosetting plastics having higher molecular weight. Next one, thermoplastics when they are get heated, they become soft, hence can be reshaped and reused. But in case of thermosetting plastics, they do not soften on heating and hence cannot be reshaped and reused. Okay. Number 5 point, reclaiming. They can be reclaimed from waste, means that thermoplastics can be get reclaimed from the waste, and thermosetting plastics cannot be reclaimed from the waste because they are not get softened by heating, cannot be get reshaped, cannot be get reused, we can say cannot be get reclaimed. Okay, the chemical bonding in the both the plastics, here the intermolecular bonds are weaker in the thermoplastics, and in the case of thermosetting plastics, they are joined by strong covalent bond, means that the network type of structure in the thermosetting plastics is bonded by covalent bonds. In case of nature, the thermoplastics are softer, weaker and less brittle. Thermosetting plastics are they are harder, stronger and more brittle. Next one point, solubility. About the solubility of both the plastics, the thermoplastics are soluble in suitable organic solvents as their bonds are very weaker. Thermosetting plastics, they are insoluble in the suitable organic solvents as they are stronger, bonds are stronger. Molding, they are molded into desired shape, they are not molded into desired shape. Examples we can take here, thermoplastics example, polyethylene, polypropylene, polystyrene, cellulose come under thermoplastics, bakelite, polyester, silicone plastics, urea formaldehyde resin, epoxy resin also come under thermosetting plastics. Okay. Next one, here we have to see some comparison between plastics and resin. Plastics and resin actually. In case of structure, the plastics are basically synthetic organic materials of higher molecular weight containing limited cross-linking. Means that plastics having cross-linking but they are limited. Resin are basically the synthetic organic materials of higher molecular weight containing large number of cross-linking, nothing but the resins. About the property between plastic and resin, the plastics are here having, we can say, they are softening on heating and hardening on cooling, but in case of resin they are not get softened on heating and not get hardened on cooling. Means that reverse property here. In case of the molding, plastics are molded into desired shape because they can be get softened on heating, but in case of resins they are not get molded into desired shape because they are not get softened on heating. Examples of the plastics: polyethylene, polypropylene, polystyrene, polyvinyl chloride, etc. Examples of resin: bakelite, urea, formaldehyde resin, we can say epoxy resins come under resins. Next one, here we have to discuss some industrially important we can say resins. Number one, here we have to discuss here as a bakelite. Bakelite is nothing but the phenol formaldehyde resin. Phenol formaldehyde resin. And these resins, bakelite resin, can be get prepared by condensation polymerization. Means that the condensation between phenol and formaldehyde leads to the formation of novolec, after that bakelite. Okay, bakelite is a thermosetting polymer and has highly cross-linked structure. Okay, that is prepared by condensation of phenol and formaldehyde in acidic, also in alkaline medium to form novolec and rizol respectively. Means that in the first initial stage, when the phenol is get condensed with the formaldehyde in acidic and also in the basic condition. In acidic condition we are getting the Stretchen compound like this as a novolec. It is thermoplastic polymer, but bakelite is a thermosetting polymer. In case of alkaline condition, when these two monomers are get condensed, formation of Stretchen compound as a rizol, thermoplastic polymer. Okay, means that in the initial stage we are getting the two kinds of we can say monomers for the bakelite, as a novolec and rizol. Okay, after that, when these two monomers as a novolec and rizol on condensation, okay, gives bakelite as a thermosetting polymer. Novolec and rizol on heating in alkaline condition, formation of highly cross-linked branched polymer, nothing but the bakelite. So how we can synthesize the bakelite in the initial stage? By the condensation of phenol and formaldehyde in acidic and basic medium, formation of two types of compounds here. One is the novolec, second is the rizol. And in the second stage of the synthesis, when these two monomers, novolec and rizol, are get condensed into in the alkaline medium, formation of highly cross-linked polymer is nothing but the bakelite. So what is the properties and uses of this polymer? We can say thermosetting polymer, means that bakelite is the thermosetting polymer. It is hard and rigid because, as I said, thermosetting polymers are not get softened and not get hardened on cooling. Okay, it has good water repellent property. It has resistant towards acids, alkalis and organic solvents. It has also resistant to heat and cold flow. It has good machinability. The applications, or we can see uses of the bakelite in day-to-day life. We are using bakelite in day-to-day life actually. Bakelite is widely used for making electrical insulator parts. Okay, electrical insulator parts because they are electrical insulator. Okay, it is used for making switches, plugs, handles of heaters and etc. because they are electrical insulator. It is used in to make telephone parts, cabinets, TV and radios. It is used as a adhesive for water softening. It is used in the missile nose cone. It is also used for making brake linings, abrasive wheels, sand field foundry molds and sandpapers. Okay, means that in the foundry also, foundry industry also, there is use of the bakelite for the, we can say, to make the molds. Okay, these are the, we can say, applications of bakelite. We can take here example as image: switches, holders, okay, handles, bangles, telephone parts, bottles, polythene bottles, utensils, handles, okay, etc. switches. These are some applications of bakelite. Okay, the next part we will see in the coming lectures. Thank you.